Hey, this is Horner, and this is number 11 through number 20 for momentum concept questions. Whenever you catch a ball, a bass player will move his or her hand backward in the direction of the ball's motion. So when you do that, it reduces the force of impact on the player's hand, mainly because the time of impact is increased. So we're making sure that we are spreading that force over a very long time. Um, if you don't pull your hand back, you have a very small amount of time that that ball can act on your hand, and so there's a tremendous amount of force, so large force due to small time of impact. When you pull your hand back, you increase this time of impact, which really then makes the force much smaller. So the small force comes from just a very large impact time. For the next question, number 12, it says a car traveling along the highway needs certain amount of force exerted on it to stop. More stopping force is required whenever there is less distance. So if you know you've got to stop very, very short distance, so very, very quickly, you got to push harder on the brakes. So there is more force there. If there's more momentum. So if you have more mass or if you have a higher speed, either one, you're going to need more force to stop. And then finally, if you have more mass. So if you're in a big truck versus a little tiny go-kart, you definitely need to have more force because there is more momentum there. For our next question, number 13, before you jump off a step, usually bend your knees when you reach the ground. By doing this, the time of impact is about 10 times more than what it is if you're stiff-legged. If you try to stand up, if you try to just jump down with your legs straight up and down, okay? So here's a person trying to do that. Here's their body, here's their legs, and they're trying to there's their hips. So these are their legs, kneecaps. If they tried to do that, it would not be pretty. Because their legs would really be twisted and broken. The force on your legs would be about 10 times bigger. So that's why when this lady is doing the long jump and she jumps into the sand, she bends her knees. Both the sand and her legs absorb a lot of that force. And if she was doing this on concrete with her legs straight, she would break both legs, and that would just not be a pretty sight. For number 14, it says recoil is noticeable if you throw a heavy ball while standing on roller skates. So if you've ever done this before, you stand on something or you sit on a chair that's got wheels on it, if you throw it, then you'll go backwards. If instead you go through the motions of throwing the ball, but you hold on to the ball, your net recoil velocity will be 0. You're going to move back and forth, but your starting and stopping point are going to be the same. So if this is your chair, okay, and there's little wheels on it, when you are sitting in the chair, when you take the ball and you push it in this direction at first, your chair will move this way. But then when you pull it back in the other direction, your chair will move towards it again. So you'll just kind of go nee like that, and then you'll move right back to your original position. So you will not change position. Okay, you will move back and forth, but you will end up where you started in the very beginning. For number 15, it's the next one. A 1 Newton apple falls to the ground. The apple hits the ground with an impact force of, you guessed it, 1 Newton. So whatever the apple is, so here's our apple, put the little stem on it. When it hits the ground and it pushes on the ground with 1 Newton, the ground then has a normal force that exerts back up with 1 Newton. So the ground can't hit any harder than the apple hits it. Newton's third law, really easy. Number 16, a cannonball shot from a long barrel cannon travels much further and much faster than one shot from a short barrel cannon because the cannonball receives a greater impulse. With a short cannon, the same force, you'll get a very short time, and you get a much smaller impulse. So the impulse here is small. With a long cannon, you get a much bigger impulse. And if you remember, impulse is equal to mass times velocity. So if I have a really small impulse, my mass is the same size, but my velocity will really small. A bigger impulse, same mass, will give me a much higher speed. So it will travel a lot faster. So just be careful with those. The bigger the impulse, the bigger the impulse J, the bigger the speed V for the same mass. And then for a little tiny J, you're going to get a little tiny V because the mass does not change. For number 17, it says a small economy car, so here's it, and a limousine, there we go, are pushed from rest across the parking lot, equal distances with an equal force. The car that receives the greater impulse It's not the smaller car. It's actually the bigger car. The bigger car has the larger impulse. The small car is really easy to push. It doesn't push back as hard. So that takes a lot less time to move a distance. So FT will give us a very small impulse. The limo is hard to push. So our time is going to be longer. So it's going to take more time to move that distance. So the one that has the greater impulse here, it is the limo. The limo has the bigger impulse because it's force times time is much bigger. So the car that receives the greater impulse is definitely the limousine. Okay, I'm using the same amount of force, but I'm having to push it a much longer time. So that is a much bigger impulse. For number 18, this one says the momentum change of an object is equal to its impulse, which is equal to the force times time. Same thing. And number 19, in order to increase the final momentum of a golf ball, you can increase the force, so I could hit it harder. I could follow through, which gives me a longer time. And if I hit it for a longer time for the same amount of force, I'll have a bigger change in momentum. I could increase the time of contact with the ball. That does the same thing with the longer time. And if I swing really, really hard, that gives me a bigger force. So increasing the force and swinging hard usually are the same. Following through and increasing the time are the same. So if you play golf, you know that if you relax and just hit it and you follow through, you'll know you're going to have a lot longer time. You can swing a little harder, but you just don't want to overexert your muscles and have them freeze up. For number 20, this is the last one. The reason we have padded dashboards in cars is they increase the time of impact. This dashboard would. Bad. Not good for your skull at all. The time of impact would be very, very, very small, and the force would be tremendous. It would be huge. Over on this one, this is padded, so our time of impact is large, which makes our force small. Notice that the impulse is the same in each car. The problem is the time here is small, which makes this really big. Here, the time is really big, and that makes the force really small, so it makes it a safer car. And that is number 1 through number 20.